Hi learners, and welcome to today's lesson. We're going to be focusing on grade 11 trigonometry, and we'll primarily be focusing on trig equations. Now you will remember from the trig graphs that there'll be more than one values for a specific trig function. For example, if we look here on our graph, we'll see if cos theta is equal to a half, we find the solution by reading from half on the y-axis. So when cos theta is equal to a half, you'll see here that x is 60 degrees, but x is also 300 degrees. And remember that because this graph is continuous, you will find that every 360 degrees, this value here will be repeated, and every 360 degrees, this value will be repeated. We also must remember that we need to take note of our cast diagram. So we need to take note of our cast diagram. Remember, in our first quadrant, this is theta. In our second quadrant, this is theta minus, 180 minus theta. In our third quadrant, this is 180 plus theta. And in our fourth quadrant, it's 360 minus theta. So if we move on down here, you'll see there are two main recognizable types of equations with variables within these types. So today what we're going to do is we're going to focus on trying to solve for a trig equation, and then we're going to do the general solution. Now if we come down to the second page, you'll see quadrant 1. It says angle is equal to RA. This RA stands for the reference angle. In quadrant 2, the angle is equal to 180 minus the reference angle. In quadrant 3, the angle is equal to 180 plus the reference angle. And in the fourth quadrant, as I already said, it's 360 minus our reference angle. So let's look at an example in order to give us a little bit of understanding of what's going on here. Question 1 says 2 tan theta is equal to negative 5,3. And then it gives you a restriction that we are only looking for theta in the first 360 degrees. So from 0 to 360, one full cycle of a graph. So tan theta, you'll see they took the 2 and they took it across because it was being multiplied here. When we transpose it, it divides. So tan theta is equal to negative 2,65. Now, what we need to do here, to get this reference angle, you'll type second function tan, and you will not put the negative sign. You will put second function tan 2,65. So second function tan 2,65, and then you will get the answer 69. So you'll get the answer 69.325. Now, what does this negative sign here tell me? This negative sign tells me in which quadrants I need to look. Now, remember, it's tan. So we need to see in which quadrant is tan negative. And there we use our cast diagram. And we know that tan is negative in the second quadrant and tan is negative in the fourth quadrant. So if tan is in the second quadrant, again, we go back up here. It's 180 degrees minus my reference angle. So it's 180 degrees minus 69.325, which will give me theta is equal to 110,67. If I work with my fourth quadrant, it's theta is equal to 360 minus 69,325, and I'll get the answer 290,67. So what must we remember here? The first thing is anything that's in front of tan, we move it across, or anything that's in front of cos here, we move it across. In this case, we divided by 2, so we had tan theta by itself. Then we work with the second function of tan to get our reference angle. But remember, this negative sign here, we don't type it in. We only use it to tell us which quadrants we are working with. Let's move on to question 2. Question 2 says 3 cos alpha over 3 is equal to negative 2. 3 cos alpha divided by 3 is equal to negative 2. And they told us here alpha divided by 3 must be within the range 0 and 180 degrees. So you see the 3 was here in front. When we take it over, remember we are transposing. So it will be negative 2 divided by 3. So negative 2 divided by 3 will give me negative 0,66. Again, remember this negative sign here, we don't type it in when we are working the second function. We use it to tell us the quadrant. So to find my reference angle, I will put in second function of cos is equal to 48.18, second function of cos is equal to 0,66. Second function cos is equal to 0,66. Again, we don't put in the negative sign. So therefore, my reference angle will be 48,189. My reference angle is 48,189. Now, remember that negative sign. Cos is negative in the second quadrant and in the third quadrant. But remember, they told us alpha divided by 3 cannot be greater than 180. So we're working with only the second quadrant because the third quadrant will be 180 plus. So alpha divided by 3 is equal to 180 minus my reference angle, which will give me 131,81. But remember, it's alpha divided by 3. So we have to take the 3 over. We transpose it, so it becomes 131,81 times 3. So alpha is equal to 395,43 degrees. Again, note we only use quadrant 2 because of the restriction. And we only multiplied by 3 once we had established an equation. So only right at the end, once we solved all this, then only do we multiply by 3. Let's move to the next example. Cos 2x minus 30 degrees is equal to 1 over tan 59. Now they told us 2x minus 30 degrees must be within 0 to 360. That's our restriction. So cos 2x minus 30 degrees is equal to 1 over 1,66. Where did the 1,66 come from? It is tan 59. Put into your calculator, you'll get 1,66. So that means that cos 2x minus 30 degrees is equal to 0,600. This now, we'll take this, we'll say second function cos of 0,6, and I'll get my reference angle, which is 53,068. Now this here, you'll notice it's positive. Because it's positive, cos is positive in the first quadrant and the fourth quadrant. So in the first quadrant, you'll say 2x minus 30 is equal to 58,068. Now you'll see we take the 30 over. Now we solve for x here. So it's 2x is equal to, it would have been 53 plus the 30, which gave me 83 here. Then the 2 goes over. Because it's being multiplied on this side, when I take it over, I divide. So then I have x is equal to 41,53. That's in the first quadrant. In the fourth quadrant, again, 2x minus 30 is equal to 360 minus my reference angle, which is 53,068 degrees. So I take the 30 over, it becomes plus 30. So I have 2x is equal to 336,93. Again, the 2 goes over, it's transposed, and I have x is equal to 168,47. They give you another example here. So they have 5 over sine squared theta is equal to 8,27. Theta is between, there's the restriction, theta must be between 90 and 270. 1 over sine squared theta is equal to 1,654. 1, now so because this is sine squared theta, we're going to root both sides. So you root both sides. So if I root this, I'll get 1 over sine theta. If I root this 1,654, if I find the square root of 1,654, I'll get plus or minus 1,286. Then if I say 1 divided by that, because we are solving for sine theta, so 1 divided by plus or minus 1,286 is plus or minus 0,7775. So sine theta is equal to plus or minus 0,775. So my reference angle is 51,03. Now, if you look here, they told us that sine can be plus or minus. That means it can fall in all 4 quadrants. But they told us it must be between 90 and 270. So if it must be above 90, that means the first quadrant is not applicable. And if it's below 270, then the fourth quadrant is not applicable. So it can only be found in the second and third quadrants. So in quadrant 2, we get theta is equal to 180 minus our reference angle. So therefore, theta is equal to 128,96. In the third quadrant, theta is equal to 180 plus 51,03, which is 231,04. Sometimes we need to remember some of our trig rules. So the ratio of an angle is the co-ratio of another angle. For example, sine and cos are co-ratios. So sine theta will be equal to cos 90 minus theta. So we can use reduction, cast, as well as co-ratios. So here we come to the worked example here. You'll see it's got sine on this side and cos on that side. So sine 2x plus 37 degrees is equal to cos x plus 13. And they told us that x must be between 0 and 360 degrees. That's my restriction. So what they've done here now, if you look in the second step, they've taken cos and made it sine. Because remember, sine and cos are co-ratios. So you will have sine 2x plus 37 degrees is equal to sine 90 minus x plus 13 degrees. So if we reduce this, we get sine 77 minus x. Both sides are positive. So these two angles could lie in quadrant 1 or they could lie in quadrant 2. So if we say 2x plus 37 is equal to 77 minus x, because remember they are equal. So 3x, we're solving for x now. 3x is equal to 40. So therefore x is equal to 40 divided by 3. X is equal to 13.33. So that would be in the first quadrant, x is equal to 13.33. Or if you have to use a second quadrant, we'd say 180 minus 77 minus x. And there, so we'd say 2x plus 37 is equal to 103 plus x. So you'd have x is equal to 66 degrees. Now the third type that we're going to look at is a solution of an equation without a calculator. Now in order to work out a solution without a calculator, you must know your special angles. So you must know the 30 degrees, 45 degrees, and 60 degree angles. If you don't know your special angles, then you will have to use your calculator to work them out. So if we look at type 1, we're just going to look at one type in this one. 2 sine theta plus root 3 is equal to 0. So sine theta is equal to negative root 3 over 2. Now, negative, also, anytime you see root 3 over 2, you need to know that it's a 60-degree angle when it comes to sine. So then automatically, you're supposed to know or have memorized your 30 degrees, 60 degrees, and 45 degrees. So therefore, you don't use your calculator for this one because you should know it. So again, it's negative here. So that means it's the third quadrant and the fourth quadrant. So it's 180 plus 60 degrees, which is 240, or it's 360 minus 60, which is 300 degrees. Now we come to another part. Well, it's the same thing, but we've introduced something called the general solution. Now, as I said to you right at the beginning, there's more than one answer. So if I said to you cos theta is equal to a half, there's more than one answer. It could have been 60, it could have been 300. And again, every 360 degrees, that solution will apply. So because of that, because there are an infinite number of solutions, see here the word infinite number of solutions. Therefore, what we do is we do it as we've done it so far, but we introduce this thing down here where it says k is an element of the real number system and plus k times 180 if it's a tan graph, or we say plus k times 360 degrees if it's a sine graph and a cos graph. Why do we say 360 degrees for a sine graph and a cos graph? It's because the sine graph and cos graph repeat itself every 360 degrees. So in other words, it completes a full cycle in 360 degrees. But the tan graph completes a full cycle in 180 degrees. So we're going to look at an example, and we're going to see now where we introduce the plus k times 360 or plus k times 180. This is called general solution. So when they ask you, or when you see the words general solution, then you know that you need to put plus k times 180 or plus k times 360. You must also include these words. K is an element of the real number system. It's extremely important that it's there. So let's look at the example. They said tan 3x minus 24 degrees is equal to negative 19,083. Now remember, this negative sign here tells me in which quadrant I am working with. So my reference angle, so I'm going to type second function tan of 19,083 and I'll get 87 degrees. So then I say 3x minus 24 is equal to 180 minus my reference angle plus k times 180, where k is an element of the real number system. So then I bring my 24 over, so it'll be 180 minus 87 plus 24, which is 117, plus k times 180 degrees. But watch the next step here now. We need to divide by 3. So we say 117 divided by 3, 39. But we also divide this part here. So k times 180 divided by 3 will give me plus k times 60 degrees. Now the reason we use 180 is because the tan function completes a full cycle in a period of 180 degrees. Also, we're only using the first quadrant because tan, we were not using the other quadrants because of the restrictions here with tan. And in the second last line, you'll notice here the second last line, see k times 180 degrees, because this was divided by 3, this also gets divided by 3. So therefore it becomes plus k times 60 degrees. Right, we're going to look at our last example here. So we've got sine 3x is equal to cos x minus 30. Now again, you've got on this side, you've got sine, and on this side, you've got cos. So we're using our co-ratios again. This this cos becomes sine 90 minus x minus 30 degrees. So we've got sine 3x is equal to sine 120 minus x. That means, now remember this is sine and sine both are the same. We are equating 3x is equal to 120 minus x. So 3x is equal to 120 minus x plus k times 360 degrees. So if you bring the x over, it becomes 4x is equal to 120 plus k times 360. So x is therefore equal to 120 divided by 4, which is 30. And it's 360 divided by 4, which is 90. So x is equal to 30 degrees plus k times 90 degrees. Or this was for the first quadrant. Then remember, sine is positive in the first quadrant and the second quadrant. So 3x is equal to 180 minus 120 minus x plus k times 360 degrees. So 2x, where you take the x over, it becomes 3x minus x, which is equal to 180 minus 120 is 60 degrees plus k times 360. So this 2 here now must be transposed over. So it becomes 60 divided by 2, which is 30, 360 divided by 2, which is 180 degrees. And remember, k is an element of the real number system. Now, sometimes they may ask you to find a specific solution within a given interval. So that means that now we don't just say plus k times 180. They want to know if, here, see here, solve cos 2x is equal to sine negative 523 degrees for x is within this range here, minus 180 up to 180 degrees. When they ask you to do this, once you've solved it, so we solve it in the normal way, so you get your plus k times 180 plus k times 180, and k is an element of the real number system. Then we substitute. So where k is, we'll put k is equal to 0, or k is equal to plus or minus 1, or plus or minus 2. And then from there, whichever values are not in this, we throw it out. Only those values that are within this restriction we use. Well, I hope this has been helpful, and I hope it explains a little bit to you of how to use the general solution. I wish you all the best. Do take care and have a wonderful day.